Up to this point, you've worked with rational bases. However, exponential functions can have irrational bases as well. One important irrational base is the number e. The graph of y equals the sum 1 plus 1 over x has an asymptote at y equals e, or y is approximately equal to 2.71828. We can see that demonstrated in the table. For x values given, 1, 10, 100, 1000, growing exponentially, and y equals 1 plus 1 over x raised to the x power as our function being evaluated, an x value of 1 leads to a y value of 2, x10 is related to y approximately equal to 2.594, approaching e, an x value of 100 leads to a y value of 2.7 approximately, getting closer to the value of e, and an x value of 1000, y is approximately equal to 2.717. And we can see it graphically. As x approaches infinity, the graph approaches the value of e, represented by the horizontal asymptote drawn here at y equals e. Natural base exponential functions are exponential functions with base e. These functions are useful for describing continuous growth or decay. Exponential functions with base e have the same properties as other exponential functions. Problem 4. Evaluating e to the x power. How can you use a graphing calculator to evaluate e cubed? Method 1. Use the e to the x key and raise e to the third power, evaluate, and find 20.08553692. Method 2. Use the graph of y equals e to the x power, evaluate for an input of 3, and find y equals 20.085537. Method 3. Use a table of values for y equals e to the x power. X values listed on the left, y values listed on the right, and we're particularly interested with the y value associated with an x value of 3, and in this case that's shown as 20.086. So we can state all three methods agree. E cubed is approximately 20.086. Your turn. How can you use a graphing calculator to calculate e to the 8th power?